This video is about forces. We're first going to talk about what a force is. So a force is a push or pull on an object. All changes in motion are caused by force. So anytime something moves, there has to be a force applied. There is going to be math with this. We're not going to get quite to the formulas yet, but it's going to be important for you to know units. So units of force is named after Sir Isaac Newton. So the unit of force is called a Newton. Newton stands for kilograms times meters over seconds squared. There are different types of force. You're going to have to be able to identify different forces in different scenarios given to you. So some of the forces that you need to make sure you know. First one is friction. Friction is a force that opposes an object it touches. So if a car is trying to roll across one direction, friction is going to cause it another. So for example here, if this box is trying to go this way, that means friction is going the opposite way of the box trying to move. Okay. There are 4 different types: static, sliding, rolling, and fluid. Gravity. Earth's gravity acts downward towards the center of the Earth. Acceleration due to gravity is 9.8 meters per second squared. Normal force is when gravity acts on an object, but the object does not fall. There is a normal force pushing up on the object. So for example, okay, again, if you have a box on a table, since the table is not falling apart, that means that this table is putting a force on this box itself to hold the actual box up. It's stopping the box from falling down. So this is called your F normal. Anytime an object is sitting on a surface, there is a normal force. Now the word net means total or overall. Okay, so the net force is the sum of all forces on an object. What you're going to have to do is I'm going to give you what's called a force body diagram, and you have to be able to calculate net forces. It's going to be very similar to what we did with displacement in the last unit. So for example, in this picture here, you have 20 newtons going up, 20 newtons going down. So just like last unit, if the arrows are opposite to each other, these actually cancel. So this 5 newtons going to the left, there's nothing going to the right, so therefore your net force in this picture is 5 newtons left. Okay, and we'll do more examples. Balance forces is just like when we did chemical reactions and we balanced it out. Forces, when forces of the object are balanced, the net force is 0. So what's going to happen is I'm going to give you a force body diagram, and you have to be able to tell me whether it's balanced or not. Now, if the net force is 0, that means the object has no motion. Okay, no change in motion, actually. Okay, it should be no change in motion. Not that there's no motion, it's just no change in motion. So the balanced forces have equal sizes but opposite directions. So for example here, this man standing on the floor, he's got a normal force because of the floor, and he also has gravity. But he's not going up or down because those forces are canceling each other, and his net force is 0. Now, remember, if an object is moving with constant velocity, meaning the speed does not change, there is no net force. Net force equals 0. So that's coming back to this slide here. If the net force is 0, that means there's no change in motion, so that means it's a constant velocity. So constant velocity also means net force equals 0. A net force, unbalanced forces will cause, okay, key words here, will cause acceleration. So unbalanced means change in motion, which is the same thing as acceleration. Okay, so it'll cause it to either slow down, speed up, or change direction. So none of this stuff you're going to have to carry on from the previous unit to this unit. You have to know what acceleration means. So slow down, speed up, or change direction. Forces cause that. No force, then that doesn't happen. Okay, unbalanced forces. If an object is being pushed or pulled, the changing motion is caused by forces. The size may have, they may have different sizes or be in the same direction. So force body diagrams, also known as free body diagrams, this is what we're going to be concentrating on this video here. You've got to be able to either one, I'm going to give you one and you have to figure out whether it's balanced or not, or two, you're going to have to be able to draw your own. Okay, so force diagrams, you use arrows to represent the different types of forces. The size, direction, and type of force has to be given in the force body diagram. The object is usually represented by a box. So it doesn't matter, it could be a person, a dog, a plane, whatever, you always just draw a box. Okay, and you're going to draw arrows representing the different forces. So here are some as an example that I'm going to give you, and you have to calculate force. So remember, if the arrows are opposite, that means you're going to subtract. If they're in the same direction, that means you add, just like the previous unit. So here, 2 minus 2 means the F net equals 0. Okay, so this one, you have 5 going left, 20 going right, going in opposite directions. So you're going to simply do 20 minus 5, which equals 15. So your F net is 15 to the right, because that's the side that's the biggest. Okay, so this one, you have 12 going up, 24 going down. So again, opposite direction, so 24 minus 12 gives you 12, and it's going to go down. That force is causing the acceleration to go down. Okay, simple as that. Do not make it harder. Okay, now this one is going to be a little bit tricky. This is where you have to draw your own based on the scenario. So here, a book bag sitting on the floor of the classroom. So again, you just draw a box. Now you have to think about what forces are acting on your book bag. You're not touching it, it's just sitting there. So first thing you need to know is everything has gravity. So you're always going to draw FG going down. FG stands for gravity. Now, since it's sitting on the floor, it's sitting on a surface. Anytime something is sitting on the surface, that means it has an F normal. Now, also, the book bag is sitting on the floor on the classroom. It is not moving at all. This means the F net has to equal 0. What does that mean about your diagram is that the FG has to equal the Fn. And that's your first force body diagram. Okay, so again, every object should have FG going down every single time. The whole reason we have an Fn is because it's sitting on a surface, and these two arrows have to equal each other because the book bag is not changing in motion. Now, let's talk about this one. A ball rolling on the floor. Again, I don't care if it's a ball, you're going to put a box. So let's go through the same thing as the last one. What does every object have on it? And that's going to be gravity. So you're going to write Fg. Okay, now it's on the floor, so it's on a surface again. So since it's on a surface, you're going to have Fn, that normal force. Anytime there's a surface, there has to be a normal force. Now, the ball is rolling on the floor. Okay, it doesn't say that you're pushing it, it's just rolling by itself. Okay, it's already been pushed, it's already rolling. Now let's say it's rolling to the right. If it's rolling to the right, that means there has to be some kind of friction. Okay, and that's it. Eventually the ball will stop. It's decelerating, it's slowing down because of that friction. This is unbalanced forces. Now 3, a ball being thrown straight up in the air. Okay, being thrown straight up in the air. Again, draw a box. Everything should have Fg. And since it's being thrown, it doesn't have an Fn this time, but it has just an F push. And that's it. Because there's no side, anything like that. There's no FN because there's no surface. Okay? You will be doing your own practice with this, and hopefully you've taken notes along with this video.